In this presentation, we will go over some examples of computing probabilities from normal distributions. Before we proceed, we should learn the syntax for the calculator to compute the normal distribution. You can find more information about this in the video entitled Calculating Normal Probabilities with the TI-83 Calculator. The syntax for the TI-83 calculator is as follows: normal CDF, A, B, mean, standard deviation. The A and the B are the endpoints of the interval for which you would like the probability, and it is a cumulative probability that we will compute. The mean is the mean of the normal distribution, and standard deviation is the standard deviation for the normal distribution. For example, if each month an American household generates an average of 28 pounds of newspapers for garbage or recycling, and the standard deviation of that distribution is 2 pounds, then what percentage of households generates between 27 and 31 pounds per month? The first thing you'll want to do to solve this problem is to sketch a normal distribution. And on that normal distribution, put the mean in the middle, 28, and the endpoints of the interval that you're interested in. And they just have to be relatively correct, that is, in relation to one another. Notice that the 27 is to the left of 28 and 31 is to the right. They aren't proportionately correct, but at least you'll have an idea of what sort of percentage to expect from this problem. The percentage appears to be greater than 50%. If you had a very small interval, you'd be able to tell that it's probably going to be a small percentage. Next, we'll type the command into the calculator, normal CDF, 27, 31, 28, 2. Once again, 27 and 31 are the endpoints of the interval. 28 is the mean of the distribution, and 2 is the standard deviation. If we have the same setup for the problem, but we want to know the percentage of households that generate less than 29 pounds per month, then the picture looks like this. Notice that I'm shading everything to the left of 29, and there is no left endpoint for this interval. One might argue that it makes no sense to have less than 0 pounds of newspaper garbage. But for the sake of consistency, anytime you have no left endpoint on an interval, we're going to use the smallest number that your calculator can represent. And that smallest number happens to be -1 with 99 zeros after it. Now there's an easy way to represent that. The way you'll do this is by using the E key. If you need help finding the E key, consult the video entitled Normal Distributions with the TI-83 calculator. In this case, I use normal CDF, -1 E99, 29, 29 is the point that I'm really interested in, 28, 2. One final version of this problem that we might encounter is in the case where you want to find the percentage of households greater than a particular number. So here's the percentage of households greater than 30.2 pounds of garbage per month. In this case, the picture looks like this, and we're interested in everything to the right of 30.2. Once again, since there is no right endpoint on this interval, I'll just use the largest possible number that our calculator can represent. And that, in that case, it is 1E99. That is the scientific notation representation for a 1 followed by 99 zeros. So the command that I'll use with our calculator is normal CDF, open parentheses, 30.2, 1E99, 28, 2, close parentheses. Every now and then you're going to be interested in finding a score for which a certain percentage of observations are to the left or right of that particular score, that particular data point. In that case, you'll be using what's called inv norm, or the inverse normal distribution. One thing I should warn you about is that the inv norm on your calculator, that command only recognizes percentages that are to the left of a particular cutoff. So to make sure that you're entering the correct syntax into your calculator, you'll want to draw a picture and read the problem correctly. Make sure that the picture matches the problem that you're reading. The syntax for inv norm is inv norm, open parentheses, p, where p represents the percentage or the proportion that you're interested in, to the left of the score. As in this diagram, the score is the right-hand side of this blue region. And then comma, mean, comma, standard deviation, close parentheses. We will use the inv norm to find cutoff points in percentiles. For example, to qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. We want to find the lowest possible score to qualify, and we're going to assume that the test scores are normally distributed. Notice that with this problem, the percentage that is given, 10%, belongs to the right of this test score, not to the left. But our calculator will only represent percentages to the left. And so I have to do a little bit of mental arithmetic, or you can do this on your calculator before I finish this problem. Specifically, if 10% of all test scores are to the right of the score I'm interested in, then 90% will be to the left. I subtract 10% from 100% to get 90%. And so when I use the calculator to solve this problem, I'm going to enter 90%. Specifically, I'll use inv norm of 90%, 0.90, comma 200, comma 20, and that gives me an answer of 225.6. And that would be the test score that only 10% of the candidates would score higher than that score. Another similar example is this one, in which the waiting time at a certain bank is approximately normally distributed. The mean is 3.7 minutes and standard deviation is 1.4 minutes. The bank would like to claim that 95% of all customers are waited on by a teller within a certain number of minutes. And we're going to find that number of minutes for the bank. Here's a picture of what the normal distribution looks like. I put 3.7 at the middle because that's the mean of the distribution. And I'm interested in the number for which 95% of all customers have to wait less than that number. And so notice that I've shaded to the left of the number I'm interested in. And the 95% represents that shaded area. To compute this value of x, I'll use inv norm of 0.95, comma 3.7, comma 1.4. And that results in a value of 6. And so this bank can safely say that 95% of its customers will be served within 6 minutes. As you know, percentiles represent a similar idea. That is, the percentile represents the percentage of observations that are lower than a particular observation. And so the calculator input makes sense in terms of percentiles. To show example of percentiles, let's take a look at an IQ test in which 100 is the mean and the standard deviation is 15. If I want to find the percentile rank of an adult whose IQ is 88, then I need to compute the percentage of adults who have IQs that are less than 88. I'll use the normal CDF function. And even though it doesn't make sense to think of a person with an IQ less than 0, as I mentioned before, for consistency, we'll use -1E99 for the smallest number possible. So it's normal CDF, that small number, comma 88, comma 100, comma 15. And that will give me the percentage of people that are between, well, 0 and 88. If I want to find the percentile rank of an adult whose IQ was 138, I would do something similar. Normal CDF, small number, which might as well be 0. Then 138, which will be the right endpoint of that interval. 100 for the mean, standard deviation of 15. Here's the actual output from the calculator for those two problems. And you can see that for the first problem, the percentile rank of an adult with an IQ of 88 is 21, the 21st percentile. And the percentile rank of an adult with an IQ of 138 is 99.4, the 99.4th percentile. We can work the opposite direction and ask for the IQ that corresponds with the 20th percentile. For that, we'll use the invnorm function, invnorm 0.20, 100, and 15. And if we want to find the IQ that corresponds with the 94th percentile, it's a very similar expression. Here's the actual screenshot of the calculator output. And you can see from this that the 20th percentile would correspond with an IQ of about 87.4, and the 94th percentile would correspond with an IQ of about 123.3.